Good morning, dear students. Last class have told problems from exercise 10.3. I've did like all these problems on general form of equations of straight line. Under general form of equation of straight line, have told some important formulas. With the help of those formulas only, I have solved some different kinds of problems from exercise 10.3. That is slope-intercept form, intercept form and normal form. To all these three forms, how we are going to converting the given problems into all these forms, I have told about all these in the previous class. Today also we are going to solving some different types of problems from exercise 10.3. Today we are going to solving how to find out distance of a point from a point to the line and how to find out distance between the parallel lines. About all these problems today we will discuss. In the previous class I did some problems on normal form, that is how we converted that given problem into the normal form. About all these we have discussed in the previous class. Now let us we are going to starting that some different kinds of problems from the exercise 10.3 now. Find the distance of the points. Find the distance. Find the distance of the points. Distance of the points. Find the distance of the point minus 1, 1 minus 1, 1 from the line. From the line 12 of x plus 6. 12 of x plus 6 is equal to 5 of y minus 2. 5 of y minus 2 they gave here. See here, they did not give equation in the form of ax plus by plus c is equal to 0. That's why first we are going to converting this into standard form first. At the same time, we have to apply the length of the perpendicular distance from the point to the line. That formula here we have to apply. How means I will show you. Now let us we are going to solving the solution of this problem. Let the given equation let the given equation 12 of x plus 6 is equal to 5 of y minus 2. 12x plus 12 6 72 is equal to 5y minus 10. And send these to this side and they are becoming here negative here. 12x minus 5y plus 72 plus 10 is equal to 0. That is the 12x minus 5y plus 82 is equal to 0. We got that required equation of line this is. They did not give equation directly. On simplification we got this. At the same time, from the point p minus 1, 1 to this line, they are asking distance. See, diagrammatically I am showing here. Here one point is that. Here one point is that just to consider coordinates of p as minus 1, 1. That is x1, y1 this is. From this, one line is there. That line is line equation they gave here, 12x minus 5y plus 82 is equal to 0 here. At the same time, just to compare this line equation with the general form of equation of straight line, ax plus by plus c is equal to 0, that is a is equal to 12 and b is equal to minus 5 and c is equal to 82 here. Now here we have to apply the length of the perpendicular distance from point P to the line distance. Just to consider capital letter D here. D here. For D formula, length of the perpendicular distance formula, D is equal to modulus of ax1 plus by1 plus c whole dividing by square root of a square plus b square. This formula here we have to apply. That is D is equal to capital letter D is equal to, here I am going to writing the values. D is equal to modulus of ax1, that is 12 into minus 1, 12 into minus 1 plus by1 minus 5 into 1 plus c, that is 82 whole dividing by square root of a square 12 square plus minus 5 whole square, and at the modulus this. D is equal to modulus of 12 into minus 1 minus 12 minus 5 into 1 minus 5 plus 82 whole dividing by square root of 144 plus 25, it is under modulus. D is equal to 82 minus 17. 82 minus 17 will get 65 here. 65 here, because 17 if you can add here, 12, 82 will get whole dividing by square root of 169. That is D is equal to, we can tell here, 65 whole dividing by square root of 169 becomes 13. On gets cancellations here, 13 are 13 5s are. Therefore D is equal to here 5 units. 5 units. It is the length of the perpendicular. Or we can call it in another way, that is the perpendicular distance from a point to the line, or we can call it in another way, the length, the distance of the point to the line. That's why in 3 ways we can call this: length of the perpendicular, or perpendicular distance, or distance of a point to the line. All these 3 are giving the same meaning here. So finally, with the help of this formula, we got the length of the perpendicular from a point P onto the line is D is equal to 5 units. Like that, we give solution to this question. Because here they did not give equation of line directly. First, you convert that equation of line in general form, that is in the general form of ax plus by plus c is equal to 0. And afterwards, with the help of the point and line, just we have applied this formula. With the help of this formula, finally we got the distance is your 5 units. Like that, we give solution for this question. Now let us, we are going to solving another question. Next question is, find the points, find the points, find the points find the points on the x-axis, on the x-axis, on the x-axis whose distance from, whose distance from, whose distance from whose distances from the line, from the line x by 3 minus y by 4, x by 3 minus y by 4 is equal to 1, x by 3 minus y by 4 is equal to 1 or 4 units, or 4 units. X by 3 minus y by 4 is equal to 1 or 4 units the mentioned here. See here also they did not give directly in the form of general form of equation of straight line. That's what firstly you convert into general form of equation of straight line for the given equation of line. At the same time, the point they gave on x-axis. If any point lies on x-axis, then its coordinates always in the form of x comma 0. That's what here y coordinate is 0. See here, from x comma 0 at the same time they gave distance also here. D is equal to 4 they gave. With the help of these two, we are going to finding coordinates of given point here. See how to solve. I will show the solution for this question. Now let us, we are going to giving the solution for this question. Solution for this question is, let the given line, let the given line, let the given line x by 3 minus y by 4 is equal to 1. LCM is 12. Taking cross multiplication, 4x minus 3y is equal to 1 here. Taking cross multiplication, 4x minus 3y is equal to 12. And 4x minus 3y minus 12 is equal to 0, which is our required equation of straight line for this problem. At the same time, they give point is, point P is equal to, we can take here x comma 0 because they mentioned the point on x-axis. Points on the x-axis they mentioned. At the same time, one more they gave, D is equal to 4 they gave here. From all this, it just we considered it is x1 comma y1 this is. And it is, see here, see diagrammatically if you can observe here, up to that so just if you can what they gave in the problem, up to that I have written. See diagrammatically I am showing here, here point is there, P is x comma 0. That's what just we considered coordinates of P as x1 comma y1 here. From that one line, from that point to the line equation also they mentioned here. What is the line equation here? We got 4x minus 3y minus 12 is equal to 0. At the same time, D is equal to, they gave 4 here. Up to this distance is 4 they gave here. At the same time, just comparing with the general form of equation of straight line, ax plus by plus c is equal to 0 here. A is equal to 4 and b is equal to minus 3 and C is equal to minus 12 here. All these three we got here. Now we have to apply length of the perpendicular formula, that is capital letter D is equal to modulus of ax1 plus by1 plus c whole dividing by square root of a square plus b square. A square plus b square it is. Now d's, what is the d value here? 4. Otherwise I'll give solution here. 4 is equal to modulus of ax1, 4 into x 4x plus minus 3 into 0 0 minus 0 plus 0. Next c value is minus 12 whole dividing by square root of a square is 4 square plus minus 3 whole square modulus it is. 4 is equal to modulus of 4x minus 12 whole dividing by square root of 16 plus 9 here. 4 is equal to modulus of 4x minus 12 whole dividing by square root of 25 becomes, it is the, we can write 4x minus 12 whole dividing by square root of 25. Square root of 25 becomes 5 here. Taking cross multiplication, modulus of 4x minus 12 is equal to 20. Just here modulus is there. If you can see that left hand side part is under modulus. Just if you can remove modulus, then RHS part becomes plus or minus. That's what I am going to removing here modulus, then right hand side part becomes here plus or minus 20 here. That's why in both cases we are going to get in the value of x. In case 1, just we are going to equate into plus 12, and in case 2 we are going to equate into minus 12 here. How means I will show this. 4x minus 12 is equal to 20. 4x is equal to 20 plus 12. 4x is equal to 32. X is equal to 32 by 4. On gets the cancellations here, x is equal to 8. At the same time here also 4x minus 12. 4x minus 12 is equal to minus 20. 4x is equal to minus 20 plus 12. 4x is equal to minus 8. X is equal to minus 8 by 4. On gets the cancellations here, x is equal to minus 2. Like that, in two ways we are getting the value of x here. One time we equated to plus 20. Another time we equated to this minus 20. By equating like that, in those two ways, by equating 20 here, in first case we got x equal to 8, in second case we got x equal to minus 2. Very simple. They gave here distance, points, a line, but here we are going to finding coordinates of point here. For that point also they have mentioned that the point is lies on x-axis. That's what, with the help of that cause only I have taken coordinates of point P as x comma 0, because if any point lies on x-axis, y coordinate or ordinate value, or we can call it in another way, the second coordinate is always equal to 0. With the help of that I have written here P is equal to x comma 0. And after, with the help of all these three, I applied this formula. In that formula we substituted known values. With the help of known values we found the unknown value, that is x. That's what point becomes. P is equal to, we can tell P is equal to 8 comma 0 or we can take p is equal to minus 2 comma 0, like that. There are two possibilities are there to get the coordinates of point p on x-axis. The p is equal to 8 comma 0, or we can write coordinates for p as minus 2 comma 0, like that. We give solution for this question. Now let us, we are going to solving another question. Third question. Find the distance between the two parallel lines. Find the distance. Find the distance between the two parallel lines. Distance between the two parallel lines. Two parallel lines. First question is parallel lines means 15x plus 8y minus 34 is equal to 0, and 15x plus 8y plus 31 is equal to 0 here. Here see, they have mentioned about the two lines, they are parallel lines. How we are going to telling the given two lines are parallel lines means, just if we can observe the coefficients of x and y in these lines, they are same, but constants are different. That's why whenever constants are different, at the same time coefficients of x and y are same in the given two lines means we can call them as parallel lines. See, at the same time they are asking distance between the two parallel lines. That's why here we have to apply what is the formula for distance between the two parallel lines. We have to apply that formula. See, I will show diagrammatically. At the same time I am going to giving solution for this question also. Solution for this question is say here one parallel lines. It is one parallel line. Just to consider this, it is the 15x plus 8y minus 34 is equal to 0, first line, and second line is L2, 15x plus 8y plus 8y plus 31 is equal to 0. Just to consider distance between the two parallel lines with the capital letter G here, D here. It is D. Just to consider with comparing with, that is the ax plus comparison with ax plus by plus c2 is equal to 0, that is, and it is comparing with ax plus by plus c1 is equal to 0, this is. That's why here in these two lines, if you can observe, coefficients of x and y, they are same, but difference is there between the constants of the given two lines. And for this I am going to applying the distance between the two parallel lines. The distance between the two parallel lines. the distance between the two parallel lines is given by d is equal to modulus of C2 minus C1 whole dividing by square root of a square plus b square. Otherwise, you can take C1 minus C2 also, no problem. Is equal to, I am going to substituting those values here. D is equal to modulus of C2 value is 31 minus C1 value is C2 minus C1 value is minus 34. Otherwise, you can take a C1 minus C2 also, no problem. Whole dividing by square root of 15 square plus 8 square. D is equal to modulus of 31 minus 2 minus plus 34 whole dividing by square root of 225 plus 64. D is equal to modulus of 65 whole dividing by square root of 289. D is equal to, we can take here modulus of 65 whole dividing by square root of 289 can be written as 17 here. That's what finally we can write distance between the two parallel lines is 65 by 17 units. That is like that we are giving a solution for this question. Because to choosing that parallel lines is very simple. In any two lines, the coefficients of x and y are same and constants are different. Means in that time we are going to calling those given two lines are parallel lines. That's why here in this question coefficients of x and y are same but constants are different. Constants are different means those given two lines are parallel lines. For these two parallel lines, I have taken this formula. D is equal to modulus of C2 minus C1 whole dividing by square root of a square plus b square. And with help of this formula, finally we got D is equal to 65 whole dividing by 17 units. Like that we give solution for this question. Let us now we are going to solving another question. Next question is, find the distance between the two parallel lines. First, second, third, fourth question here. Find the distance between the two parallel lines. Find the distance between the two parallel lines. Two parallel lines L of x plus y. L of x plus y is plus p is equal to 0. And L of x plus y minus r is equal to 0. Here they gave two lines, L of x plus y plus p is equal to 0 and L of x plus y minus r is equal to 0 here. First we convert those given two lines into the standard forms, and afterwards we have to check whether the coefficients of x and y are the same or not. We have to check about them also. See here, I'll show you how to solve this question. At the same time, I am going to giving solution for this question solution here. Solution for this question is the, let the given two lines, let the given two lines L of x plus y plus p is equal to 0 here. That is, we can take Lx plus Ly plus p is equal to 0, and L of x plus y minus r is equal to 0. That is Lx plus Ly minus r is equal to 0 here. So here diagrammatically I am showing here, it is L1. L1 means here Lx plus small letter Ly plus p is equal to 0. It is comparison with ax plus by plus c1 is equal to 0 here. At the same time, second line L2 here, Lx plus Ly minus r is equal to 0, comparing with ax plus by plus c2 is equal to 0 here. Here d is equal to here d, distance between the two pair lines. D is equal to, for that we can write here d is equal to, we can take here modulus of c2 minus c1 whole dividing by square root of a square plus b square. We have to apply this formula here. D is equal to modulus of c2 value is minus r minus c1 value is p whole dividing by square root of a value is l square, b value also l square. It is equal to we can write here d is equal to, take minus common, then we will get minus of r plus p whole dividing by 2l square here, because l square plus l square becomes, what we can write here, l square plus l square about this 2l square. It is under modulus, no, we can take it as positively, because distance is always measured in positive level. Because of that only here have taken d is equal to, we can take here d is equal to r plus p whole dividing by root 2 l units. This is the answer for this question is. Otherwise you can take modulus, is no problem like this. Root u r plus p whole dividing by root 2 l units, because they are not giving that is, they did not give any values in instead of or and instead of p also. That's why I have written as it is, that is we got a formula in terms of r comma p and l. That's what here finally we have written the distance between the two given parallel lines is d is equal to modulus of r plus p whole dividing by root 2 l units. Like that we give solution for this question. Now let us, we are going to solving another questions. Next question is, find the equation of line. Find the equation of line. Find the equation of line find the equation of line parallel to the line, parallel to the line, parallel to the line 3x minus 4y, 3x minus 4y plus 2 is equal to 0, and passing through the points, and passing through the points, and passing through the points, passing through the point is minus 2 comma 3 here. See here, one equation they gave, so the equation of line is 3x minus 4y plus 2 is equal to 0. To that one more line is passing. Already I have told about that formula also. Equation of any line parallel to the given line ax plus by plus c is equal to 0 is always in the form of ax plus by plus k is equal to 0. That formula here we are going to applying. See, firstly I am going to showing with help of diagrammatically, and afterwards I will give a solution for this question also. Now let us we are going to giving solution for this question. Solution for this question is, here one line is there, just consider that line is 3x minus 4y plus 2 is equal to 0, and one more line parallel here. Parallel line means already I have told also. In the previous question also we observed some lines in case of parallel. In case of parallel lines, the coefficients of x and y are same but constants are different. That's why according to those rules we can write equation for this line is 3x minus 4y plus k is equal to 0. That's why at the same time they mentioned this is the passing through point is p is they mentioned minus 2 comma 3 here. Now we are going to apply this formula. It is L1 and it is also, just to consider, it is the L2. This is, these lines are parallel to each other. Now we are going to writing first formula. Otherwise let the given equation of line, let the given line, let the given line 3x minus 4y plus 2 is equal to 0. Equation of any line, equation of any line parallel to the line, equation of any line parallel to the line, parallel to the line 3x minus 4y plus 2 is equal to 0 is always in the form of, is always in the form of 3x minus 4y plus k is equal to 0. Just to consider equation number 1. Just I change only constants only here. At the same time, which is passing through which points, and which is passing through, which is passing through the point, which is passing through the point, which is passing to the point minus 2 comma 3 here, Whenever it is passing through minus 2 comma 3, definitely instead of x we are going to take minus 2, instead of y we are going to plus 3 here. Say here 3 of minus 2 plus minus 4 of 3 plus k is equal to 0 here, minus 6 minus 12 plus k is equal to 0 here. That is 3 into minus 2 minus 6 minus 4 into 3 minus 12 minus 18 plus k is equal to 0 here, k is equal to here plus 18. That's why put k is equal to 18 in 1. Put k is equal to 18 in 1. That is, we can write here required equation 3x minus 4y plus 18 is equal to 0 here. It is the required equation of straight line. Like that, we gave solution for this question. They gave line equation. To that, one more line is parallel. At the same time, parallel line is must be passing through a point also they gave here. Like that, today we solved some different types of questions, and we did questions on perpendicular distance. We did questions on how to find out distance between the parallel lines. At the same time, just now we did how to find out the equation of a line parallel to a given line. Like that, we have finished some different types of questions from the exercise 10.3. Next class also I am going to solving some different kinds of questions on from the exercise 10.3, but we'll solve like all those questions on next class. Thank you very much.